Okay, here we go for the back page. Also, just for your information, I was right. The one on the last problem we did, number 6, it graphs a rational function. The asymptote, this vertical asymptote, is at 5/4. So that's where it doesn't have a hole because it was an x over an x, or an x squared over an x squared. It's a rational function, but its vertical asymptote was there at 5/4, which is what our limit was. So anyway, now you know. Okay, looking at these, it says to evaluate the limits using any appropriate method. The methods you're looking at are by graphing and by plugging in your answer. Or I guess using logic would be one too, but a graph is helpful in that matter. So if we look at number 7, we want the limit as x approaches 1 of 2x squared minus 6. So we can just start by plugging in, and if you can plug in, all the more merrier to you. 1 squared minus 6. This gives us 1 squared is 1 times 2 is 2 minus 6 equals negative 4. So the limit is negative 4. Easy as can be. When we look here at number 8, it gives us an infinity. You can't really plug infinity in. So you can think logically here. If I think about x squared plus 2x, if I plug in 5, that's going to give me 25 plus 10, 35. If I plug in 100, that's going to give me a really big number plus 200. If I plug in 1,000, that's going to give me a really, really big number plus 2,000. The bigger my x's get, it's just going to keep getting bigger. I literally cannot think of a very large number for x where my y value will get smaller. Everything about this is in an increasing motion. If you want to know what the graph looks like, this is a quadratic when you've got that x squared. It just doesn't have like a plus 3 at the end. It's a plus 0, 1 at the end. It has moved left a little bit, so it looks like this. Okay, and you can see as we approach infinity, as my x keeps going this way, so as I keep traveling to the right on my graph, but we follow the line, but I'm going right, my y value just keeps going off up into infinity. Okay, so whenever it goes off into infinity, we say it does not exist. Okay, because any number I plug in for x, any increasing x value I plug in, my y value will continue to increase. There is no limit to how big my answer could be. Okay, number 9. 9 and 10 is when they start being mean. This is when they're just putting a lot of pre-cal work into later things. There are times you'll do stuff like this in calculus, but they're not going to, especially 10, they're not going to put that much identity work into finding the limit because that's not the purpose of all of this. However, it's good to kind of get some pre-cal refreshers while looking at this new concept of limits. So, number 9, we've got the limit as x approaches pi over 2, cosine of x over sine squared x. We are just going to plug in like we've been doing. So we want to know the cosine of pi over 2 over sine squared of pi over 2. If you think about your unit circle, pi over 2 is right up here. So this is the point 0, 1. And we said that in your coordinate point, it always goes cosine comma sine. Again, you can type this into your calculator if you like. Make sure if you're typing in a pi over 2, make sure you're in radian mode though. So the cosine of pi over 2 is 0. The sine of pi over 2 is 1, and we're going to square that because it's sine squared. So we get 0 over 1 squared, which is 0 over 1, which is just 0. So the limit of this is 0. That means if you were to look at your cosine function, as you get here to pi over 2, okay, from both directions, you are approaching 0 at that point on the graph. Number 10, hint, simplify and then evaluate. It's like, oh, thank you so much. I'm so happy. Okay, we need to make this look prettier because we cannot plug 0 degrees in. Basically, if you've got a fraction happening here where your denominator is 0, we lucked out that the sine of pi over 2 is 1. If that had been 0, we would have had to do some factoring to make that denominator not go to 0. Here, if we plug 0 into secant squared, that's 1 over cosine, which then, trust me on this one, that 1 over cosine, that you end up with a 0 between all of these sine over cosines, 1 over sine, 1 over cosine. You end up with zeros in your denominator, which you cannot have in your problem at all whatsoever. So here we go. Cotangent squared is cosine squared over sine squared. I'm not going to write my thetas because that's next to impossible on this thing. Just writing in general. There we go. Minus 1 over sine squared. All of that is going to be over secant, which is 1 over cosine squared. Lucky for us, on the top we have a common denominator, so we can write this as cosine squared minus 1 over sine squared over 1 minus cosine squared. If you remember back to all those identities, which you're going to need to remember for your final, so the identity we had with a cosine or sine squared and 1, the identity is actually 1 minus cosine squared equals sine squared. We are close to that. So if we think about rewriting this as negative 1 plus cosine squared, okay, because my 1 is negative and my cosine is positive, then I'm just rearranging the order. Now I'm going to factor out a negative 1. This is called tricky math. It's just manipulating. This is the only time in your life that manipulation is a good thing. You're going to manipulate your problem to do exactly what you want it to do. So we factor out a negative 1. Now we have a positive 1. Now we have minus cosine squared, which is super helpful because now when we come back down here, I'm going to change this cosine squared minus 1. It's now going to be negative 1 times sine squared over sine squared all over 1 over cosine squared. Did you hear my laundry being done? Isn't that exciting? Lucky for us, that goes away. So now we have negative 1 divided by 1 over cosine squared. I'm going to go ahead and bring up my 1 over cosine squared because I'm going to lose it in just a second. And we're going to make this, it doesn't want to do it, there we go. I'm going to make this times cosine squared over 1. Okay, when I look at that, now on the top I have negative 1 times cosine squared. I'm going to leave it written as negative 1 instead of just negative cosine squared because remembering your negative rules and order of operations here can be a little tricky. I'm going to go ahead and throw my theta back in because we're near the end. Over 1, so yippee skippy, we've simplified this now. We haven't even answered the question, but now we're simplified. Do you remember doing these? It was so fun. Now we've got it simplified. Negative 1 times cosine squared of theta. Our theta is 0 degrees. Feel free to type it into your calculator, or you can just remember that when you're on your unit circle, so here's my unit circle again. I'll go purple. Here's where 0 degrees is. That's the point 1 comma 0. Cosine always comes first, so my cosine is 1. See? So then we've got negative 1. Oops, let's go back to blue. Negative 1 times 1 equals negative 1. So the limit as x approaches 0 degrees of cotangent squared minus cosecant squared divided by secant squared equals negative 1. Yay! Okay, do your best through these. Honestly, I am not overly stressed about them. The ones that are more simple, like this, understanding the do not exist, where you're just plugging in a number, or where you're looking at the graphs themselves, those I want you to be able to find the limit of. So the 1s and 2s where you're looking at the graph, the 5s and 6s on these problems where you're factoring and then just plugging in that number, that's where I want your focus to be. Do not spend too much time on the back pages of these. Do your best when you're grading these and tell your parents, just be super generous. We're going to go with a, like, I put forth an effort. This is going for completion, not accuracy. I'm probably just going to just give you all 100 for the worksheet pages of this, but I want you to attempt these problems, but I don't want you to stress about the problems. So focus on the first page of each lesson, because that's the more of the style of question I'll use on the exam and where I need your brain to be strong with. Now, the ending ones are not bad because they're getting you some practice of things that are on your final. So let me know if you have any questions. Oh man, like 30C number 10, it wants you to use Pascal's triangle, the binomial theorem, to expand x plus 3 cubed. I mean, it's good for you, but again, it's quarantine life, so you can just give a big ol' X and be like, no thank you, Swindell. And I'm totally fine with that. I just want you to dabble in these. So anyway, that's all I have here. Now that I have 2 super long videos, have fun with limits, and you'll hear me next for your final review.